Solve some problems here in mole conversions. Okay, determine how many atoms are present in 2.5 moles of silicon. So we're given here 2.5 moles of silicon, and then we need to convert this into atoms. So that will be 2.5 moles of silicon, and then by using the Avogadro's number, which is equal to 6.022 times 10 to the 23rd atoms, so we just multiply this by 6.022 times 10 to the 23rd atoms silicon per 1 mole silicon, and this one cancels out, so our answer would be 2.5 times 6.022 times 10 to the 23rd atoms, so we have 15.05 times 10 to the 23rd atoms of silicon. Okay, let's solve this next problem here. How many moles of silicon is 3.01 times 10 to the 23rd atoms? So we're given here the number of atoms, and we convert this into moles. So this would be 3.01 times 10 to the 23rd atoms of silicon times 1 mole of silicon is just equivalent to 6.022 times 10 to the 23rd atoms silicon. Okay, and this one cancels out, so our answer would be 3.1 times 10 to the 23rd divided by 6.022 times 10 to the 23rd is just equivalent to 0.5 mole silicon. Okay, what is the mass of 4 moles of iron? So we're given here the number of moles of iron, and then we convert this into grams. Okay, so 4 moles of iron, and then we need the molar mass of iron. So molar mass of iron is just 55.9 grams per mole from the periodic table. So we multiply this by 55.9 grams per mole iron. Okay, and this cancels out the mole. So this is just equal to 224 grams of iron. So that is 4 times 55.9. Okay. The next problem is how many atoms are in 48.6 grams of magnesium? So we convert, we're given here the grams, number of grams of magnesium, and then we convert this into atoms. So 48.6 grams of magnesium. Okay, we need the molar mass of magnesium from the periodic table. So there will be 1 mole of magnesium is just equal to 24.3 grams magnesium, and then multiplied by the number of atoms per mole of magnesium using the Avogadro's number, that is 6.022 times 10 to the 23rd atoms magnesium per mole magnesium. So the grams cancelled here, and then the number of moles. So our answer would be 12.04 times 10 to the 23rd atoms magnesium. So you just divide 48.6 by 24.3 and then multiplied by the Avogadro's number. Problem here. How many grams are in 18.06 times 10 to the 23rd atoms of copper? So we're given here the number of atoms and we convert this into grams. So that will be 18.06 times 10 to the 23rd atoms of copper times 1 mole of copper is equivalent to 6.022 times 10 to the 23rd atoms of copper multiplied by the molar mass of copper, which is just equal to 63.5 grams of copper per 1 mole of copper. So atoms here cancel out as well as the number of moles. So our answer would be, we just divide this one by this and then multiply it by 63.5. So we get 190.5 grams of copper. Okay, next of nickel is 176 grams. So we're given here the number of grams of nickel and then we convert this into number of moles. So that would be 176 grams of nickel. We multiply this by the molar mass of nickel. So that is 1 mole of nickel is just equal to 58.7 grams of nickel. Okay, and then the grams here cancel out. So that would be equal to 3 moles of nickel. Let's solve this other problem here. What is the volume of 9.36 grams of methane gas, which has a chemical formula of CH4 at STP? STP is read as standard temperature and pressure. So we're given here the number of grams and we need to convert this into liters. So that would be 9.36 grams of methane multiplied by its molar mass, formula mass. So that would be 1 mole of methane is equivalent to 16.04 grams of methane. Then multiplied by the volume per mole of methane gas at STP. So that would be 22.4 liters per mole. So this one cancel out and also this one. So our answer would be 9.36 divided by 16.04 times 22.4 liters. So our answer would be 13.1 liters methane gas.